Alright, just going to record a video demonstrating tracking for a landing just before we destroy the drone in an actual test, at least get some simulation data. Alright, so let's take a look at the environment. Here we have the M100 hooked up. It's running in the DJI Assistant 2 in the simulator environment. And just some IMU information, nothing interesting. Alright, just to make the test interesting, we're going to add some wind speed. Our PID does have an integrating term, so it should have no problems dealing with wind. And just to verify the wind is in effect, there you can see it. It's slightly tilted. It's fighting against the wind. Just making sure. Alright, let's move over to the simulator side. Just a quick explanation. Here we have a vehicle, and here's our map coordinates. Note these map coordinates are in east, north, up. So this is north. So this is going with the wind, and this is going against the wind down this side of the track. And you'll see the result of that. And here we have velocity control for our vehicle. And these units are in centimeters per second. So I can speed all the way up to 10 meters per second. But let's just keep it at 8. Alright, so here we go. Let's run the simulation. Make sure to switch the remote to accept API calls. And off we go. Alright, so let me explain some of these windows. So here we have the PID controls. The PID controls are done on the ground axis for X and Y, and we're using roll and pitch controls because we want acceleration based controls to follow a constant velocity. And the yaw here is a rate based. And you can see in the simulator the M100 is directly above the truck, and it's currently fighting against the wind, and we'll see that here. So currently it's following distance, and the XY plane is 1 meter behind because it's fighting against the wind. And down here landing, when that's a -1, means it's attempting a landing, and that only happens when it's slightly under half a meter behind. So now it's going with the wind. You can see right here, easily has no problem keeping up, and it's starting to land, indicated by this -1. And just take a look at that PID. Let me zoom out on that thing a little bit. There we go. Alright. So it's currently running at about vehicle at 8 meters per second, and just to make sure that's actually running at 8 meters per second, let's take a look at this window, and you can take a look right there. It's running at 8 meters per second, and the only reason why it's taking so long to land is because I set the drone's height at about I think 50 meters, and I set the descending speed at 1 meter per second, so it's going to take at least 50 seconds to get down. But that gives us at least 15 seconds to observe it flying around. So let's move back here, and we last looked, it was about 10 meters above, so it's about to perform a landing. And let's just have fun and switch up the speed up to 10 meters per second to see if it can keep up. So it's falling a little behind, but with the wind behind it, it should have no problems keeping up. And as we can see, it has no problems keeping up. It's currently performing landing, and it should be landing any moment now. And there we go, it landed. That's why it stopped falling. So there I've demonstrated in the simulation that our drone can track a vehicle up to 10 meters per second, which is slightly above 20 miles per hour. Alright, hope you enjoyed the show. Hopefully this goes as we planned in the real live testing. If not, we'll have a dead drone on our hands. Alright.